Welcome. I'm here today to discuss two mobile apps that I have developed using Android Studio. The first app I created was WorldTime. The plan for this app was to develop a method for a user to be able to set and quickly view the local times for different time zones in the world. I started by creating two activities, one for the quick display of the time zones and the other was for the selection of the time zones. Within the main activity, the selected time zones are displayed programmatically. I was oblivious at this stage to the functionality and use of Recycler View, so I instead created a grid layout with nested text views for each new time zone. With enough time zones, this would eventually crash the app. To be able to set the padding for these views so that they'd fit correctly to the screen, I had to get a pixel measurement from an inputted density. To do this, I did some research and came across getDisplayMetrics, which provided the device's density needed for the calculation. I also had to update the time for the time zones when the device time changed. I was unsure about how to do this, and after some research, I simply implemented a timer that updated them every 10 seconds. In the new time zone activity, the user was shown one or two spinners to select the area and region from. The region spinner was programmatically updated when the area was selected to show the regions within that area. If the area did not have any further regions, the region spinner would be invisible. The regions were populated by the spinners were populated using string arrays, which are all set up by hand in an XML file. The selected zones class was created to help store and retrieve the time zones that the user had selected. I did add a method within the class to be able to remove time zones, however, this was never implemented. The zone class was created to handle setting the default time zone and returning information about a passed-in time zone object. The getTimeZone method took a parameter of a string and returned a time zone object. The rest of the methods are self-explanatory getter methods. The ZoneTime class automatically converts a passed-in time zone object to a calendar object, which is then used to build a string for displaying the time. The second app I developed was 99 Problems. The inspiration for this app came from a minigame in Final Fantasy IV Heroes of Light, although I did put my own spin on it and change some of the rules. The gameplay of 99 Problems is to add, subtract, multiply, and divide a set of 4 random one-digit numbers to be able to finish with 10. For this idea, I knew straight away I needed a homepage and a game page activity. However, I also opted to implement a leaderboard and an options activity. The home screen is just for allowing the user to have direction. The gameplay activity handles user input and display for the game, apart from calculations, which are handled in the calculator class. The 4 numbers the user can select from are provided using the inbuilt random class. When the user selects one of the 4 numbers, the gameplay activity runs on click, which calls the calculator class. Selecting a number within the equation turns that number to 0, allowing the user to select a new number. However, if the result is clicked and is not 0, this will replace one of the random numbers that was selected, and the other number will be removed. The user can only skip a few times, default is set to 5, and will be shown toasts when they get close to running out. However, this skip meter is reset whenever a user manages to score a point. When the user is finished playing, a blocks will be displayed using frame layout with the user's score, an edit text for a username, and a button to go to the home screen and a button to share. To reset the random numbers, the user must shake the device. This will call a sensor event listener and onSensor changed to check the intensity. If it is high enough, a rewind sound will play and the numbers will be set to their original values and made visible. However, there is a known bug. If the device was rotated in quick succession, all the numbers that should have been saved will be turned to 0, forcing the user to skip to keep playing. This was fixed by setting the activity's orientation to portrait. For the leaderboard activity, I initially intended to have a worldwide leaderboard. Instead, I opted for a local leaderboard using an SQLite database. To gain access to the database, I implemented a helper class that utilizes several SQLite APIs. When a user opens the leaderboard activity, the helper class gets the table, or creates it if it doesn't exist, with all the usernames and scores to be displayed. A score is added to the database within the gameplay class when a user scores 1 or more points and inputs the username. The database is displayed on the leaderboard using a recycler view. The displaying of this view is handled by a self-made adapter class extending recycler view's adapter API. This adapter also inflates the recycler view's cards using an inbuilt method that was overridden to show the items within the string list, usernames, and scores, which are updated using the database's information. For the options activity, I decided to implement a dark mode and a feature for the user to select the range for the leaderboard. The dark mode is activated using a switch, and Android allowed the entire app to use dark mode while this was activated. The range has a default of 10. If the user changed the range, their leaderboard would display up to that many items. Working with Android Studio to develop mobile applications was occasionally frustrating, although it was very interesting and enjoyable. There were a few APIs that I needed to research, however, I genuinely cherished working with Android Studio, and I certainly will continue to work with this program. I believe that for proper implementation, quite a bit more work is needed, although the methods I used worked well and Android Studio was quite easy to learn, especially with the amazing developers website. Thank you.